Today we're covering some examples in preparation for section 5.6. It'll be super helpful if we're really solid on these types of problems where you have to solve for x inside of either an exponential equation or a logarithmic equation. So that's what we're practicing here today. For a quick reminder, we have our log definition at the top, y equals log base a of x, and that correlates to the exact same equation as x equals a to the y. And then we also have our three different log rules here, which are very useful to keep at the top of our mind. So looking in at our first example, we have 2 to the 3x minus 7 equals 32. This is the type of example where the right-hand side can be written as the same base as the left-hand side, because 32 equals 2 to the 5. So if I have 2 to the 3x minus 7 equals 2 to the 5, well, I can just take 3x minus 7 equals 5. And now this is a really simple algebra problem that we've seen 100 times in this course. I add 7 to both sides, I get 3x equals 12. I divide both sides by 3, and I get x equals 4. So that's the first problem type that we could see. Now a different problem type we see in part B, where we have 4 times 2 e to the x, 4 times e to the 2x equals 400. And we want to solve for that x. Now, x is in the exponent, so we want to keep in mind that we will be taking a log, or actually a natural log here, since we have a base e. But first, we need to have e alone. So we need to divide that 4 over to the right-hand side. And we get e to the 2x equals 100. Now we can take the natural log of both sides. ln of e to the 2x equals ln of 100. And we know that the natural log and e cancel out. So we get 2x equals ln of 100. And so x equals ln of 100 over 2. And that's the exact answer. You could put that in your calculator to get a decimal. But if you ever ask for the exact answer, you want to leave it in terms of the natural log. So now, looking at the next problem, we're actually given x inside of a log. And so using our log definition, this can be rewritten as 3 to the minus 2 equals x. And let's just look at that definition with it just for a second. We have base 3, which means my a value is 3. It equals negative 2, so that becomes my exponent. And of course, what we're taking the log of becomes x. There's a few different ways to think about this one. You could take 3 to the both sides. Like I said, a few different methods. Here, I think the easiest one is just to rewrite it. We immediately get what x equals, 3 to the minus 2, which of course 3 to the minus 2 is 1 over 3 squared, which is 1 over 9. So we could say x equals 1 over 9 here. Now looking at the last one, it actually has some logs that we need to combine first. So we need to use a log rule so that we have a log statement with one log statement with x's in it. And that way we aren't trying to solve it with two different logs here. So using our addition rule, or our product rule, we're going to go from this addition to a product. And we get log of x times x plus 3. And that, of course, still equals 1. That, of course, is log base 10. So if I do 10 to the both sides, I'm looking at x times x plus 3 equals 10. Now that mainly comes from the fact that the log and the raising to the 10 cancel each other out. That's why I have x times x plus 3 on the right, or on the left. And on the right, I have 10 to the 1, which is just 10. So now I can distribute my x. I'm looking at x squared plus 3x equals 10. And so I subtract 10 to the other side, and I'm looking at x squared plus 3x minus 10 equals 0. That, of course, is something that we can factor. So we have x plus 5 and x minus 2 equals 0. That's something we've done 100 times in this course. So, of course, we get x equals negative 5 and x equals 2. Now, x equals 2 we like, but x equals negative 5, we actually can't include that in our solution set. We actually need to throw this one out. We cannot take the log of a negative number. Therefore, x equals negative 5 is not in the domain of this function. Therefore, we throw it out and we only have x equals 2 as our solution. So give these a practice. There's a whole bunch of problems here for you to work through, a lot of these different kinds of techniques, and it's a great preparation for the test coming up next week. There's certain to be several of these on your test coming up. As always, reach out if you have any questions.